Alright, so let's take a look at this packet number 7. And just as a reminder, we have this week and then next week, and that'll finish up our class. Alright, so for this week we're just going to do a summary of everything that we've learned so far. So if you could open up packet number 7, we'll just start working from the beginning and get as far as we can today. So for the first problem, it's asking us to classify the following as rational or irrational. So you have to try to remember what those words mean. Rational, you could think of as orderly. Irrational, you could think of as disorderly. All right, more specifically, rational numbers you could write as a fraction, as decimals, they repeat, or they terminate, or they end. Irrational numbers you can't write as a fraction. And as decimals, they don't repeat, and they also don't end. So an example of an irrational number would be like the square root of 3. Any kind of imperfect radical would be an example of an irrational number. Typically people use pi, or sometimes people even use like an imaginary number. That wouldn't be like a really good example, but like the square root of 3, pi, sometimes even like the number e. Those are all examples of irrational numbers, or 0.1357, etc. They don't have any order. Rational numbers would be written as a fraction or perfect square roots. So if we take a look at our options, classify the following as rational or irrational. We have -3. We have the square root of 3, the square root of 16, and 2 pi. Now, anytime you multiply a rational number by an irrational number, you always get an irrational number. We talked about the square root of 3 as an imperfect square root, so we call that irrational. Square root of 16 is a perfect root, so we call that a rational number. And -3 would also be considered a rational number. For number 2, it says let A represent a non-zero rational number. So A is rational. And it says let B represent an irrational number. Which of the following expression could represent a rational number? So we have -b, a plus b, a to the second, and then we have 2b squared. Well, sometimes the best way to do these problems is to pick numbers. So a rational number maybe use like 2. We're just plugging in numbers. An irrational number, let's maybe pick the square root of 3. All right. So negative the square root of 3 is still irrational. 2 plus the square root of 3 is still irrational. You can't combine those. A squared, 2 squared is 4. 4 is considered rational. And then 2 times b squared. Well, the square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is 3. 2 times 3 is 6, which is considered rational. So which expression could represent a rational number? Looks like this one and this one. Just remember, sometimes when you have an irrational number times itself, sometimes that could produce a rational number. And we've seen this before in the notes, and we're seeing it again now with this example. where you have an irrational number times itself. All right, so going down to part B. Part B says, consider a quadratic equation with integer coefficients and two distinct zeros. If one zero is irrational, which statement is true about the other zero? Well, we talked about this also, that if 1, 0 is irrational, both zeros are irrational. They come in pairs. So if you have one irrational zero, you also have another one. So let's see. So for part I, it says the other zero must be rational. That's false. So the other zero is rational. That can't be true. Part 2, it's saying that the other zero is irrational. And that is correct. Part 3, it's saying the other zero could be either rational or irrational. That's not true. They come in pairs, so it has to be irrational. And then the other one says the other zero must be non-real. The answer is if one zero is irrational, they have to come in pairs. You have an irrational zero, and you also have another irrational zero. And looking at problem number 3, it says looking at the graph, write the coordinates of the zeros. So for problem number 3, the graph looks something like this. Now zeros mean x-intercepts. So it looks like it crosses at -2. It looks like it crosses at 1, and it crosses at 2. And it crosses the y-axis at 4. So let's see here. Something like that. What are the coordinates of the zeros? Well, the coordinates of the zeros would be -2, 0, 1, 0, and 2, 0. So let's see what the options are. And we want to write our zeros with the number in front followed by 0. So these are all x-intercepts because the y is equal to 0. We can't use b. B can't be an answer, and d can't be an answer because that's how you write a y-intercept. That's not a 0. Of the ones that are left, 2 zeros, one of the ones we listed, not -1, 0. And not -3. So it looks like the only answer that we could use here is A. Number 4, circle all the zeros of the function f of x is equal to x squared minus x minus 2 times x plus 3. And the way that we said we could do this is we could either factor or we could plug in. And I've encouraged you to just plug in. I think that's the easiest way to do this. So let's write our answer choices. Now, answer choice A is 2, 0, 0, 4, -1, 0, 0, 2, and -3, 0. Okay, we know it can't be these two because those two are considered y-intercepts. It's asking us for a 0, and what a 0 means is that means an x-intercept. It's going to be written like this, x, 0. So let's see which of these, if we plug in, we get 0. If we were to plug in -3 for x, -3 would make that part 0, and if you multiply 0 times anything else, you would get 0. So E is definitely an answer. All right, so now let's try negative 1 and 2. If we plug those in here, like let's try negative 1 comma 0. We get negative 1 squared minus negative 1 minus 2 times negative 1 plus 3. Well, that turns into 1 plus 1 minus 2 times 2. This is 0, so the whole thing is 0. So negative 1, 0 would definitely be an option. And then let's try that last one, 2 comma 0. If we plug in 2, we get 2 squared minus 2 times 2 plus 3. 4 minus 2 is 0, and 0 times 5 is 0, so that works also. So the answers for this would be A, C, and E. Move on to number 5. Number 5, it's saying we would like to simplify the following. Now what simplify means is it just means combine like terms. So for part A, it's telling us we have x squared plus 3x minus 4 minus 2x squared minus 2x plus 5. Now anytime we see parentheses, we should always look to multiply by whatever number's in front to get rid of the parentheses. This would give us x squared plus 3x minus 4, and then negative 2x squared plus 2x minus 5. Combine our like terms. We have a pair of x squareds. We could write negative x squared. 3x plus 2x is 5x. And then negative 4 minus 5 is negative 9. For part A, that would be the simplified expression. For part B, it's saying we have x to the 4th minus 3x to the 3rd minus 5x to the 4th plus 2x squared minus 3x to the 3rd. Like term means it's the same variable and the same power. So I see an x to the 4th here. Here's another x to the 4th. 1x to the 4th minus 5 is negative 4x to the 4th. We have negative 3x to the 3rd. We have negative 3x to the 3rd. That's negative 6x to the 3rd. And then we have a 2x squared left over. That would be the answer for part B. Part C, it gives us a FOIL kind of problem. Anytime we see parentheses next to parentheses, we're remembering to FOIL. And what FOIL stands for is we multiply the first terms together. That would be these two. So x squared times 2x squared. Then we multiply the outer terms together. You can always put a plus sign here. The outer terms would be x squared times negative 3x. We multiply the inner terms together. Negative 3 times 2x squared. And then we have the last terms. Negative 3 times negative 3x. Remember, anytime you multiply the same letters, you add the powers. So like we do 1 times 2 here, but we have x squared times x to the 2nd. We add 2 plus 2, and that's x to the 4th. Positive 1 times negative 3 is negative 3. X to the 2nd times x to the 1st, we add 2 plus 1 is 3. Negative 3 times 2 is negative 6. And then we just have the x squared. And then negative 3 times negative 3 is positive 9x. That would be the answer for part C. So that's all the time we have for today. Stay tuned, and we'll talk about some more problems tomorrow. Thank you very much. Have a nice day.